Hi, this lesson we will look at the median of a continuous random variable. The median is defined as the value which divides the area under the probability density functions into two equal halves. Hence, median, let's say we use capital M, of a continuous random variable is that value for which when I find the probability that less than equals to the M, the median, means I'm going to integrate the PDF, right? From the lowest limit until the median, the probability must be equals to 0.5. Okay, let's have a look of example 1. Let X be the continuous random variable having probability density functions, right, given here. State the value of A and find the median of the value of X. So as what we can see, this PDF given is a simple horizontal line, Y, because the PDF function is a constant A. All right. That means this is the A. And the limit is taking from 0 until 3. So what is the value of A? In my previous video, I explained that a PDF given, hence the area under the graph must be equals to 1, right? Because that is the probability, and probability lies in between 0 and 1. So to find out the value of A, we know that this rectangle must be 1. So how do we find a rectangle area? 3 times A equals to 1. And that's what we can determine the value of A equals to 1 over 3. So from this PDF given here, we have found the value of A, and then we are going to find out the median of X. According to the explanation here, the value of the median, right, it must be a value in between 0 and 3. And then it divides the area under the PDF into two equal halves. So as I'm taking a simple linear graph, that means it's a simple horizontal line here. So we can see easily that the median must be a value lies in the middle, which is 1.5, and so that it cuts the area into two equal halves, right? 0.5 each. Hence, median found equals to 1.5. All right, so that is answering this example 1. Now we move on to the second example here. Right, let X be the continuous random variable having PDF. Okay, now you are given the PDF and you can see that it's a 2x. It's a linear graph. Find the median value of X. So let's have a quick sketch of these linear functions in between 0 and 1. So we try to sketch this. The straight line graph will cut through the 0 and has a gradient of 2. And we will stop at 1. All right, so this is the median. This is the PDF sketch, and we are trying to find out the median. That means we know the median will lie in between 0 and 1. But as you can see, this area is a triangle area. So if the value of X in the middle, 0.5, Do you think that this value 0.5 cuts the area into 2 equal halves? It does not. All right. Hence, we can tell the median should be a value that lies in between 0.5 to 1. All right. So how are we going to find out the median? So let's say I label the median somewhere here, label as capital M. So as you can see, this value of M more likely to cut the area into 2 equal halves, right? This area is 0.5 and as well as this area to be 0.5. So now we are trying to carry out the calculations. So that means if I'm going to find the probability of the x less than equals to M, the median, that means I'm going to integrate from the lower limit, value 0, until the median of the PDF to x respect to x. And this area must be equals to half or 0.5. All right. So we are going to integrate this straight line graph and we are getting this. Equals to half. All right. So we can simplify it. And we sub in the limit M squared and then the lower limit 0 squared. So finally, the M is going to be the square root of half. So, and we can see that based on the discussions, look at the PDF given, we know the median value has to be greater than 0. Mean must be greater than 0. Hence, the answer of the median is this. Then we can find out the value by using calculator. So the value is 0.707, right? Which is consistent with what I mentioned just now. The median is a value at here slightly greater than 0.5 and less than 1. So 0.707. So this value is the median and it cuts the area under the graph into 2 equal halves. Right? That is how we calculate and find out the median. Okay, now have a look at one past year questions. All right. So this is the question from October-November 2016, variant 7.1. Right, question 6. So the diagrams shows the probability density functions of 4 random variables, w, x, y, z. Each of the 4 variables takes values between 0 and 3, right? 0 until 3, 0, 3, 0, 3, 0, and 3. And their medians, right? We are looking for the medians are given as small letter m for median of w and x, y, and z accordingly. Okay, now what are we going to do? List the median of them in order of size, starting with the largest. All right, so let's see. For these 4 PDF given here, we can see the main difference are the W and X are curved and the Y and Z are straight lines, right? So you can see that the Y is similar to the previous example. It's a straight line graph. And then let's start from here. So we know that value of the median must be in between 0 and 3, right? And you can see if 1.5 is not going to cut the area into 2 equal halves. So we know the median will be shifted towards the right side a bit, somewhere around here, right? So that the area under the graph will be equals to 0.5 into 2 equal halves. So we're expecting the median for y around 2, right? Somewhere between 1.5 and 2. So can you see the z will be the opposite of it? Because of the graph, the straight line graph, it has a triangle shape. And then if you look at the middle, 1.5, then you also know that 1.5 will not be the median. And for the median, in order for the value to be cutting the graph so that the area under the graph into 2 equal half, it has to be shifted towards the left, right? So it has to be a value somewhere in between 1 and 1.5, and so that the area under the graph will be half each. So can you see? Means the median of y must be greater than median of z. Okay, then the problem is, how do we interpret the w and x? So you can see y and x, they are just same type of the graph, just that the y is a straight line, the x is a curve. So simply means the median will be, if the value in the middle between 0 and 3 is 1.5. For this curve, the median will be shifted further towards the right, right? So that the area under the graph of the median will be equal to 0.5 each. So by looking at this, we know that the median for the x must be greater than median of the y. Then for the same comparison, the w and z, they are similar type of graph, okay? But then the curve will be shifted towards the left even further for the median, so that this one has to shift further to the left, somewhere here, so that the area will be equal to 0.5 for each half. Okay, so that means the median of z greater than median of w. So now we are going to list down the median starting from the largest. So as we can tell, based on this conclusion that we obtained so far, the largest median has to be the median of x, right? Because of the curve shape, the median will be shifted to the right most, so that the area under the graph will be 2 equal halves, then followed by the median of y, then followed by median of z, and the last one, median of w. So this question is to show you that without calculating the value of the median based on the graph, the curve or the straight line graphs given, we are able to tell where the median supposed to lie. Okay. Important thing, the median is a value that cuts the area into 2 equal halves. Okay, let's see the next example. So this is the questions. from 2015 October, November, also variant 7.1, question 4. So a random variable x has this PDF. Okay, we can tell this PDF is a straight line graph and the limits from 1 to 2 and k is a constant. So in order to show that k equals to 2 over 3, again, very important point, when this is a PDF, the area under the graph means we are going to integrate this graph, these functions must be equals to 1 from the limits 1 to 2. Okay, so that is how we start and try to integrate this. Right? Okay, we sub in the limits. Then calculate from here. 326 minus 4 over 2, 2. And then minus 3. Minus minus become plus half. So we are getting 3 over 2. And then, hence, k is going to be 2 over 3. Right? We have shown. Okay, now we are trying to answer part 2. Find the median of x. So we want to find median of x, and this is the functions given here. So what do is, we know median is a value that lies between 1 and 2, and important thing is it cuts the area under the graph into 2 equal halves. So I'm going to take the lower limit 1 until the median using capital M to represent it, and k is a constant, can put aside, integrate the functions. Respect to x, and it must be equals to half. Okay, so that is how we start calculating to find median. With the k value have shown in part 1, just put 2 over 3, and we integrate this. All right, and now we sub in the limits. Okay, 2 over 3 can put it to the right and getting 3 over 4. Okay, now try to simplify this. 3 minus half, right? 2.5. So minus 5 over 2, 3 over 4. So can you see what are we getting here? We are getting a quadratic equations. So we are trying to solve a quadratic equations. Bring everything to the right hand side. So 3 over 4 plus 5 over 2. 13/4. Right? Then we try to times 4. So let's see if we are able to factorize it. Okay, cannot factorize, then we are trying to use the formula to find out the solutions. Okay. So one of the value 4.58, another value 1.42. All right. So can you see? Based on these particular questions, to find out the median value of x, it has to be a value that lies in between 1 and 2. So even though we have solved the quadratic equation form and found the two values of n, but we know the value of m must be in between. M is greater than 1, less than equals to 2. So hence, the median, equals to 1.42. All right, that is how we managed to get the median for this particular PDF given. All right, so that is what I want to discuss for today's lessons, finding the median of a continuous random variable. That's all for this lesson. Please subscribe to the channel and like these lessons, and see you in the next. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.